Today we are covering lesson 5, measuring 3D shapes, surface area, and volume. Our goal today is to determine the surface area of any 3D shape and also to determine the volume of any 3D object or shape. You will need the formula sheet, which is the first one you were given, finding area or circumference. In this case, you find the perimeter. You said the circumference of a circle is another name for the perimeter, or the distance around the circle. And we said that's just 2 times pi times the radius. So distance around the circle. We also need to know or use the formula for finding the area of a rectangle, which we know is length times the width, and also the area of a circle. Okay, so this is what we've covered so far, surface area. We'll extend that today into 3D objects, and the other formulas you'll need are here in your booklet, but we also have, this is one, finding this surface area of 3D objects. So we'll be looking at a couple of these 3D objects today in today's lesson. More specifically, we're looking at a cylinder and a triangular prism. The surface, and also we're looking at the volume formula. Find the volume of a rectangle as well as a pyramid or a cylinder or a triangular prism. Now there's one sheet that you have. Your formula sheet covers both of these. On the flip side of your formula sheet that you're given, if you don't have it with you, it's at the back of your booklet. And here the formula for the figure, the diagram of that figure, and the surface area of this figure, which is in this rectangular solid. It's like a box, a paper tissue box is a good example. And then we have the formula for that, how we find the surface area. And then the formula for volume. So on this column, we have figure name, the diagram, the surface area, and the volume formula. So this is the formula sheet we're referring to, although they're separate ones. So this is your reference, so make sure you have this handy with you. And you'll need a good old tried calculator here to help you to go along. Let me clear my calculator here. So let's go straight. Let's look. So our goal then is to determine the surface area. So by the end of this lesson, you'll be given a 3D object, in this case, a cylinder. It's on a flat surface. It's not a 2D surface, but it's a 3D object. And you will be asked to find the surface area of the cylinder and its volume. Then the next example I'll go through with you is what we call triangular prism. And you'll become familiar with the names of these on your formula sheet here. It has the figure name. So you have a box, for example, it's called a rectangular solid. A sphere, like a basketball or a football or a soccer ball, I should say. It's a sphere. Cone. We look at the cylinder and square base pyramid and triangular prism. For today's lesson, I'll go through how to find the surface area of this triangular prism and its volume. So we'll be given the formulas. So the surface area is the formula, and this is the volume. And we'll look at the cylinder for today. find the surface area of a cylinder, and find its volume. So by the end of today's lesson, you will be able to determine, through using the formulas, the surface area of a cylinder, and then the surface area of a triangular prism. But let's look at some background information before I go into finding the surface area of the cylinder. One of the things you have to remember, that surface area, so go back, this is some of your notes in your booklet. Surface area is exactly the same as area. So when we were finding the area of these shapes here, like rectangle, square, triangle, or circle, we were finding the space within the given figure. Now, surface area refers to the same thing. Yeah, you're given the figure, what's the space inside? Now, when it comes to surface area of a 3D object now, we're looking at, let's look at a can, or a soup can, or any kind of a can. You have top and the bottom, a lid, top and the bottom. If you were to draw a series of squares around it and count the number of squares, that's the surface area. Here's an illustration. If you were to draw a series of squares, each top and bottom, but also there's an area under the can below. This is the top, but there's also the bottom of the can. And you were to count all of the squares, that gives you the surface area. So that's what you'd be finding. For example, in this case, a cylinder. This is a circle here. You'd be finding the area of the circle and a circle at the bottom here. Then we find the area of the sides. So the 3D object like itself essentially, the 3D object is a collection. If we go back to the first one here, the 3D object, the surface area of the 3D object, is a collection of 2D shapes. This is a 2D shape, a circle here. And we go back to our formula sheet we have. It's a collection of these 2D shapes. So when we look at a cylinder, it's two circles and a rectangle, and I'll explain to you what that means. So when we are looking at surface area, for a cylinder, we're looking at the top and the bottom. And if you were to strip a canister apart, it will look like this. The sides will look like this, and the circles. Now, I have an illustration here, model. Now, this is, now it can't probably get difficult to see it, right? This would be a cylinder. Try to make a cylinder here. Imagine a soup can. You have the top, you have the bottom. Now, if I want to find, this is the side of it, if I want to find the surface area of this here, if I were to tear it apart, this is what I'll get. I'll end up with a rectangle and two circles. We know how to find the area of a rectangle. We know its length times the width. And the area of a circle, so the area of the circle is pi r squared. And there are two of them. So here we have pi r squared. So we have length times width. So that's a cylinder. It's really two circles, the surface area, and a rectangle. But when you put it back into its original shape, it doesn't look like that. But that's what it is really. That's what I meant by taking the 3D object apart. Your reality is made up of 3 two-dimensional shapes. So a cylinder is made of 3 two-dimensional shapes. 2 circles, so we have here, and a rectangle. Fortunately for you, the formula is given, but that's in reality what you're doing. You find the surface area of a rectangle and the surface area of the 2 circles. Now, if we were to look at this is the side of the rectangle, right? If you were to rip it apart, but it's actually a circle. If you look at it here, it's a circle. Okay. Now, the distance around a circle is called the circumference. If you go back to our formula, the distance around the circle, it's the perimeter, the circumference, and it's 2 pi r. So now we settle. So if you were to go back to find the distance around the circle, which would be the side here is 2 pi r. So this would be, this is your 2 pi r distance around, so circumference here, which is similar to your width when you have a rectangle. So 2 pi r times the h will give you the side of the cylinder. So when you want to find the area of this side of the cylinder, it's pi r to 2 pi r. Now, but we also have the height. So the distance around here is 2 pi r, then we have the height. That's why the area of the side of a cylinder is 2 pi times the radius times the height. And the circle is pi r squared. We'll know the radius, we'll find the height. So to conclude now, the surface area of a cylinder is 2 pi r plus pi r squared. This is your circle. Right. This is your side. Now, because if you look at any cylinder that has a top and the bottom, then you'll put 2 here. You do the top and the bottom. Now let's look at the formula and break it apart now. This is our formula for surface area. It's 2 pi r times the height, which we know we got from here. That's the side. There are 2 circles. Now one circle, go back to our formula here. One circle is pi r squared, but there are 2. So we have a top and a bottom. So bottom or top is one of those, but there are 2. So we can put here top and bottom. In reality, what you have here are 2 circles and a rectangle. So we'll be making use of this fact to find the surface area. Now, when it comes to volume, which we'll look at next, the volume is the amount of space between this object here. Let's say we have a cylinder. The volume refers to how much space is in it. So when we get the volume, we'll get into the volume formula. Let's look at the first example question here. This will make more sense. Find the surface area and the volume. So we'll find the surface area first, but let's look at step number 1. We write down the formula. surface area. And we go to our formula sheet. And that's 2 pi r times height plus 2 pi r squared. So we can see here, surface area, and we can look at the sides, which is 2 pi r times the height plus the top and bottom. Two pi r squared. Okay, so I'm utilizing surface area, the side, and top and bottom. Next, what I would like to do is to record what's my dimension. I need height and I need radius. So let's find the height here is 20. So I put h equal 20 centimeters. Now, here we go. The radius would be half of the diameter here. So this is our center. So the radius would be 6.5 centimeters here. This would be 6.5 centimeters. So radius is 6.5 centimeters. Now we have our dimensions. We now substitute our given values here into our formula. So we have 2 pi, radius is 6.5. I just put bracket to replace multiplication, times 20 plus 2 times pi times the radius of 6.5 to the power 2. Now I'll need my reliable calculator, do some work. Let's shift over here. So 2 pi r, so 2 times pi times 6.5 times 20. And that would give me 816.814 goes on, plus, now we have 2 times pi times now 6.5 to the power 2. Make sure you put that down. I'm squaring it. That gives me 265.46. These are all in centimeters square. Now add those two. So we get plus 816.8140.899. Gives me an answer of 1082.2. I'll round this up to 2 decimal places. That will give me 0.27.28 centimeter square. So surface area is 1082.28. Sure this shows up well. 10 centimeters squared. Now let's look on to volume. So put a line across here. Because the next step is to find the volume. Volume, when we're looking at volume, we're looking at the amount of space within any object. Now, there's an illustration in your booklet regarding volume. Well, this has to do with a solid, a rectangular solid. Nevertheless, it illustrates what a volume is. The volume is used to measure three-dimensional objects, but it measures the amount of space. So here you have a box. The amount of space within this box refers to volume. So if you were to look at this box and you find, and you measure in cubic unit, for example, in this case we have centimeters, number of cubes. If you were to have 1 cube, how many cubes 1 cubic centimeter will fit into this box? That's what you're asking. In the case of a cylinder, refers to how much space would be inside of this cylinder. Now, if we think of, let's pull this guy out from here. This is the bottom of a cylinder. It's a circle. Okay, I'll just remove this from here. And we were to start, now we know the area for this, which is pi r squared. And volume, basically what you're doing is you have a stack of these going up. So that's why we could say the volume of a cylinder is pi r squared times the height. So let's say I have a cylinder here, and I know the side of it. This is your, really hard to see here, but this you'll have your height of a cylinder. And this is your area. So all what you're doing, you're taking infinite amount of these and you add them up. And that's your volume. So volume is pi r squared times the height. So if you were to look at this cylinder here, you have the area of the top here, which we know is pi r squared. So what's the top? And then we add a series of them. Essentially what you're doing, you're multiplying. So volume of a cylinder is equal to pi r squared times the height. So this would be a top and a bottom. And as you go series them up, you're adding these pi r squares. The cylinder. So volume is pi r squared times h. I know from here that the height is 20, the radius is 6.5. So I substitute those values. I'll record them here again. H is equal to 20 centimeters. The radius is 6.5. I'm going to substitute those values. 20 will replace H, and 6.5 will replace R. So volume is pi times 6.5 to the power 2 multiplied by 20. So get my good old calculator here, do some work for me. Should you put this over here? So I go pi first, then I multiply by 6.5 squared. multiplied by 20. And it gives me 2654.65 cubic centimeters. Because we're working in 3 dimensions now, we have to add the cubic to it, or to the power 3. I'll explain. So volume is 2655.65 cubic centimeters. Note the surface area was to the power 2, but volume is cubic because we're dealing with 3 dimensions. Here we have r squared, and you have another dimension of 3 dimensions. So we're looking at 3 dimensions for here. In surface area, we're looking at a 2D space, not a 3D. So volume is 3D. So we can put that aside. The volume is 3 dimensions. Surface area is 2 dimensions. That's why we say surface area will be cubic centimeters squared, or square centimeters, and volume is cubic centimeter. The next, we will look at the surface area of a triangular prism. So this is called a triangular prism. That here. The formula for a triangular prism with here 2, one that we look at is a surface area. Now, if you look at a triangular prism, the front of it, if you look at it from this perspective, I mean the other perspective, the front of it here is a triangle. So to find the surface area, so the front would be a triangle, the back of it also here would be another triangle. The triangle of the front and the back will be the same area, same dimension, assuming it's a triangular prism. Then we have 3 sides. We have one side here and another side, the other, and one at the bottom. So we have 3 sides. So we have these 3 lateral sides and the front and the back. Altogether 5 sides. Now, the formula to find the surface area is that once we label A, B, and C, the size of the front of it, which is a triangle, and the length of the prism, we multiply each by A, B, and C. Essentially what you're doing, you're finding the area of the side here, to find the area of the other side, and the bottom, and then the area of the triangle. Now, since there are 2 triangles, we don't need to use base times height divided by 2, because the area of a triangle is base times height divided by 2. But since there are 2 of them, there are 2 triangles, these 2 will cancel out. Oops, you can see that. I'll redo it again. Area of a triangle is equal to base times height divided by 2. In other words, base times height divided by 2. Now there are 2 triangles, so we multiply them by 2. If you multiply by 2, these 2 becomes 1. So that's why we can say base times height. So this is the area of the triangles. There are 2 triangles here. And this is the area, these are the area here, for the 3 other sides. So the front and the back, you could call this the front and the back, or top and the bottom, depending on your perspective. That's the surface area of the front here, pi r squared, base times height, and this is your back. Now you can go about finding them separately. You can say find the area of the triangle here, find the area of the other triangle, find each side, and you'll arrive at the same answer. But by using this formula, you are making your work much more efficient. So we apply this formula here. So let's look at the surface area first. So surface area is equal to base times height plus the length A plus B plus C. Or write it as base times height plus L into A plus B plus C. Now we want to label our sides based on our formula. So to make it work, what you simply refer to your formula sheet here. Okay. Now this is you can label the front of A, this would be your B, this would be your C, H, and this is your L. Once you label it in this way, you then take the dimension and substitute it into your formula. So we have A, so we have A is equal to, now no value is given here, but since this is an isosceles triangle, these two angles are the same, these two sides will be the same. So this is 13 inches also. So A is 13 inches. I'll just make sure I'll write this. So you can see A, B, and C. Your H, and that's your L. B is equal to 10, and C is equal to 13. H is equal to 12, and L equals 24. We will use these values and replace the symbols or letters given here into our formula. So we have our base times height. So we have base is 10 multiplied by 12. I'll put it in brackets. Plus the length is 24. A is 13 plus B is 10. And C is 13. Now we work these numbers. 10 times 12 gives me 120 square inches plus 24. 13 plus 10, 23, 23 plus 13 give me 36. So 120 square inches plus 864 gives me a total of 984 square inches. So the total surface area of this triangular prism is 984 square centimeters. So be careful, use your formula sheet and make sure you label your diagram carefully. Do not, and refer to your formula sheet. Refer to this formula sheet here. You'll be given similar diagrams, but if sometimes it's slanted differently, but you have to make sure that your triangles are labeled properly at the front and the side is labeled as a length. the next part to find the volume. Then we'll look at our formula sheet for volume. So we finished with surface area. Now we look at the volume of a triangular prism. The volume is you have your base times the height times the length. So we are still applying the labeling, how we identify the sides. So we label the sides, and then we take the values given for each side and substitute them into our formula. Similarly, what we did is surface area. We'll do the same thing now for volume, except now volume is the base times the height times the length divided by 2, or half the base times the height times the length. So base times the height times the length, half of it gives you the volume of a triangular prism. So let's record that formula here. We have here as half base times the height times the length. Now we are going to utilize our values given here, which is half the base is 10 inches multiplied by the height, which is 12 inches, multiplied by the length, which is 24 inches. Now 10 times 20 times 24 will give us what? 2880. So let's work that out, make sure I'm in the right track here. Move this out. There we go. So we have 10 times 12 times 24, 2880. So we have half, I'll put that here, 2880, or 2880 divided by 2. Or 2880 divided by 2, 1440 cubic inches. So step 1, we have our formula. Step 2, let's go over this now. So to find the volume of a triangular prism, step 1, we write down our formula. Step 2, we'll label each side or dimension within the triangular prism. And it's A, B, C, H, and L. Once we label them, then take our values for each measurement and substitute it into our formula. Then do our computation from there on. There are four other questions: sphere, prism, cone, and pyramid in your assignment booklet. So you'll be asked now to find surface area of a rectangular solid. Therefore, you'll use this formula here. The volume, you're going to use the volume formula. Then you're asked to find the surface area of a sphere or the ball. It's pi r squared. All what you need for the sphere to find the radius, to find the surface area. And the radius, remember, the radius is half the dimension of the diameter. Now, there are times when they'll give you the circumference and you need to find the radius. And in that case, when it's given, you have to refer to your wonderful formula here. So then it'll give you the C, and you need to find R. So if that's done, and you want to find for R, so radius will be equal to the circumference divided by 2 times pi. So if they give you the circumference but not the radius, and ask to find the surface area of a sphere, or you will need to use this for the radius is equal to, I can put that here. So radius is equal to circumference divided by 2 pi. That's the sphere. Then you're asked to find for a cone. So label your cone well, because this is what we call the slant height, the L. Don't confuse it with height. Height is perpendicular to the center, and that's 90 degrees. So height, in other words, in 90 degrees means perpendicular. Do not confuse it with the slant height. That's your L. Slant height is the side of the cone, from the bottom to the top. Radius is at the base of the cone, half its diameter. You're going to find the volume, you need a radius at the height. And you also the next question we asked to find the square pyramid. It's a square pyramid in all the bottom here, this would be the same size. So if it's 10, this would be 10, that would be 10. So each side and the base, they're equal. And if they're equal, then it's base squared. So what do we have here? Base times base, or it's just 10 is 10 times 10, or 10 to the power 2, plus 2 times the base times the slant height. So be careful with this dimension here. This is the side of it, not the height.